Hello friends, welcome back. Let's look at this quadratic polynomial problem and try to solve that related to zeros of a polynomial. If alpha, beta are zeros of the polynomial x square minus 3x minus 2, then find a polynomial whose zeros are 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. So first let's try to understand what is the meaning of alpha, beta or zeros of the polynomial. So for that I will just step back and try to write like this. I'll say x square minus 3x minus 2 equal to, if alpha, beta are zeros of the polynomial, then I know I can write it as x minus alpha into x minus beta. So which is nothing but equal to x square minus of alpha plus beta into x plus alpha beta. Now you compare the coefficients of x square and x, you will see that alpha plus beta equal to minus 3 by minus 1, that's equal to 3, and also alpha beta equal to minus 2 constant term, which is nothing but equal to, if ax square plus bx plus c is a quadratic polynomial and alpha beta are its zeros, then alpha plus beta equal to minus b by a and alpha beta equal to c by a. The same thing we can also derive. Now we know alpha plus beta is 3 and alpha beta is minus 2. We have to find out the polynomial whose zeros are 1 by alpha plus 2 alpha plus beta and 1 by 2 beta plus alpha. So for that let me say this is alpha dash and this is beta dash. Now my equation what I have to frame will be like this. It will be multiplied with k first of all, because you can have constant terms of that. X square minus, can I say alpha dash plus beta dash into x plus alpha dash into beta dash. So the only work left out is find out what is alpha dash and beta dash. Then in terms of numericals, then we can directly substitute it. For that what I will do, I will say alpha dash plus beta dash. First let me calculate that. That's nothing but 1 by 2 alpha plus beta, 1 by 2 alpha plus beta plus 1 by 2 beta plus alpha. But I can write it as alpha plus beta is 3. So can I write it as alpha plus 3? 1 by alpha plus 3 plus 1 by beta plus 3. So we have alpha plus 3 and beta plus 3. If I take LCM of that, I will have alpha plus 3 into beta plus 3, and in the numerator I will have alpha plus 3 plus beta plus 3, that's nothing but alpha plus beta plus 6. So let us see what's the value of this. This is nothing but equal to, let me write it down here. I will write it down here. That's equal to alpha plus beta is 3, 3 plus 6 is 9 by alpha into beta is minus 2. If you just try to multiply this, I will have, okay, let me write down one more step. Let me not hurry through this. So I'll write down another step and I will say that's equal to alpha plus beta 3 plus 6 divided by alpha plus 3 into beta plus 3 is alpha beta plus 3 alpha plus 3 beta plus 9. That's equal to 3 plus 6 divided by alpha beta is minus 2 plus 3 into alpha plus beta, that's nothing but equal to 3 into 3 plus 9, that's equal to 9 divided by minus 2 plus 18, that's equal to 9 by 16. So we got alpha dash plus beta dash equal to 9 by 16. How we did that? We have just added them, 2 alpha plus beta, 2 beta plus alpha. We have written this as alpha plus beta, and we have written here as beta plus alpha plus beta, and we know alpha plus beta is nothing but equal to 3. So this becomes alpha plus 3 now, and this becomes beta plus 3. Now if you take LCM of that, you will have alpha plus beta plus 6. Again alpha plus beta is 3, and alpha beta is minus 2. Again here alpha plus beta is 3. You substitute them, you will get 9 by 16. Now what is alpha dash beta dash? Alpha dash beta dash is nothing but you have to multiply 1 by 2 alpha plus beta into 2 beta plus alpha. This is nothing but our denominator, and we have done that already here. The value we have got for that is, we got here 1 by 2 alpha plus beta into 2 beta plus alpha is nothing but 1 by 16. You can cross check that. So now what will be the equation? Let's have a look at the equation, how it looks like now. So the equation will be k into x square minus 9x by 16 plus 1 by 16. That will be the equation, the polynomial, that will be the polynomial whose zeros are 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. I hope you are clear with that. When you multiply 1 by 2 alpha plus beta into 2 beta plus alpha, it will become nothing but 1 by alpha plus 3 into beta plus 3, and if you simplify that, you will have that's equal to 1 by 16, which we have done already earlier. So that's about how to find out a polynomial whose zeros are in terms of the zeros of the other polynomial. We'll do one more example so that we'll get a hang of it. So I'll catch you in the next session where we'll do one more problem on the same type of. Thanks for your time. Bye for now.